All right, simplifying radicals with a variable, in this case specifically x is what I'm using for all four of them. I'm going to give you 4 examples. Top 2 I would say are easy, level 1 type of problems. It gets a little bit trickier here with this one, and then we get a little bit trickier here with that. And I'll throw another video up where I throw some real complex ones up here and we work those out. But for now, let's just stick with the basics, get the basics down, and then we'll kind of get into some tougher stuff, bump up the rigor a little bit on my next video. Okay, let's make sure we understand something. Square roots, all that it means is what number times itself would give you the value inside of the radical. So if I ask you for the square root of 64, what number times itself equals 64? 8 times 8. Okay, we should be beyond that. If you're working with this stuff, you should already have an understanding of this. Hopefully you have an understanding of this right here. If not, I'll give you a quick explanation. If you have a variable with an exponent inside of the radical, okay, you're just cutting that in half. When you square root an exponent, you just cut it in half, okay? So half of 10 is 5, boom. Well, why does that work? Because if you think of the product rule with exponents, x to the 5th power times x to the 5th power, the product rule says add the exponents together. 5 plus 5 would make the 10. So you can just cut that value in half when you're taking the square root of an exponent inside of the radical. But that's gonna cause some struggles and some issues if that value is that's an even number, so we'll be fine there. That's an odd number. That makes it a little bit trickier. We're not able to just cut 9 in half, okay? We know we would get 4.5, and we're not gonna be throwing any decimals up there. So what do we do in that case? That's the big thing I'm gonna be teaching in this lesson. Okay, here we go. You can write it out the long way if you need to. I don't think most students need to do that. I think most of them can kind of just see it. So if you want to write it out as 2 separate radicals, that's fine. Square root of 25 is 5. Square root of x to the 6th power, you're cutting the 6 in half. Sorry, the 6 looks like that. Cut the 6 in half, x to the 3rd power. Simple as that. There's not a whole lot to this, okay? So we go to that next one. These top 2 you should be able to do mentally, really. Square root of 49 is 7. Square root of x to the 12th power, cut that 12 in half, x to the 6. Put some boxes around my solution so it's clear for you guys to see. Okay, so I didn't do a whole lot of teaching with those top 2 problems, okay? They're really not that complex. But now you get down to these problems where we're dealing with some odd numbers, numbers that aren't perfect squares, 7, numbers that are odd as exponents. We gotta do some different things, okay? So pay close attention, here we go. We're gonna separate these 2 out. I didn't think you needed to separate up here. Square root of 25 is 5, square root of x to the 6th power, x to the 3rd power. Here, separating actually is helpful because I like to call that square rootable, right? It's a perfect square. We can get the square root of it. We can do it mentally. This is not square rootable, right? So what I need to do in this case, when you have an odd exponent, here it is. Are you ready? This is all you need to do. Take 1 away from it. Turn it into an 8, okay? X to the 8th power is square rootable, and I took 8 away from the 9, so over here I only have 1 left, okay? I can now cut that 8 in half and turn it into a 4. I can also square root 9 and turn it into a 3, because 3 times 3 equals 9, and x to the 4th times x to the 4th, you would add the exponents to get x to the 8th. Therefore, my square rootable section is going to turn out to be square root of 9 is 3, square root of x to the 8th power is x to the 4th power, and then I cannot square root of x, so we're just going to keep it as root x. And there's your answer right there. Put a box around it, show it off to your teacher, they're going to give you a thumbs up, moving on. Go to this problem right over here. Can you square root 7? Nope. Can you square root x to the 4th power? Yep. So we're going to separate them. Square rootable, not square rootable. All right, that should be new terminology, square rootable. Okay, cut the 4 in half, x squared. Can you square root 7? No, so we keep it as root 7. Put a box around it, make sure it's clear that's your answer, and you're good to go. And that's it. Study hard. Good luck on your upcoming test.